Here we go with section 9.2, the sampling distribution of sample proportions. So as stated in the last video, there are two types of problems. You have proportion problems that deal with categorical data, and you have mean problems that deal with quantitative data. In this section, we'll be talking primarily about proportion type problems. So the first thing is we choose an SRS of size n from a large population. So that's, again, a simple random sample of a certain size from a population, and p hat is the proportion of the sample having a desired characteristic. So we'll go back to the problem talking about ghosts, if people believe in ghosts. So what happens is, here's my population here, this group of people, and I'm going to randomly ask a certain amount of them. Let's say I ask, 100 of them, if they believe in ghosts, and a certain amount believe in ghosts, and then I plot that on a graph. All right, so I get a p hat, I plot it on a graph. Now I go and ask another 100 people, and I get another p hat, and I plot that on the graph. And I do this a repeated, a bunch of times, and I plot them all on this graph. All right, all these different p hats. Okay, and what happens is I get this approximately normal distribution. So the mean of that, I'm concerned with the mean of that, and the mean of the sampling distribution is exactly p. So we call that mu sub p hat. The mean of all the p hats is just p, which again was the true proportion of people that believe in ghosts. So this is p, and we have a formula for the standard deviation, sigma sub p hat, and that's the square root of p 1 minus p over n. And we can label this over here, sigma sub p hat. That's where we usually put the standard deviation. So essentially, we're going to be doing normal calculations, but we first have to calculate our mean and standard deviation. Now, the nice thing is that those formulas are on your reference sheet. So here's your formula sheet or reference sheet. And if you look down on the right side, right here you have mu sub p hat equals p and sigma sub p hat. And it gives you the formula for that. Okay, the z-score formula. So again, we're going to basically get a p hat. We're going to have a p and we're going to have a standard deviation. And we can get the z-score by taking p hat minus p over sigma sub p hat. And that's essentially the same as x minus mu over sigma for mean problems. Now there are two conditions that must be met, and you will use the formula for standard deviation of p hat only when the population is at least 10 times as large as the sample. So the population is greater than 10n. N is the number in the sample. And we use the normal approximation to sampling distribution of p hat for values of n and p that satisfy np greater than or equal to 10 and n 1 minus p greater than or equal to 10. And I'll show you how to use all these in a problem. So, example 1, dealing with milk. A USA Today poll asks a random sample of 1,012 U.S. adults what they do with the milk in the bowl after they have eaten the cereal. Of the respondents, 67% said they drink it. Suppose that 70% of U.S. adults actually drink the cereal. Is this surprising? Okay, so you may want to pause that to write it down. I will proceed. This 70% of U.S. adults is the parameter. That's the true proportion of U.S. adults who drink their cereal milk. Now, a sample of 1,012, 67% said they drink. So that's your p hat is 0.67, and your n in this case is 1,012. So the first thing you have to do is you have to check the conditions before we can proceed with any calculations. So the two conditions so far are the population is greater than 10n, greater than or equal to, really. So the population is greater than or equal to 10 times 1,012, which is population greater than or equal to 1012, so 10,000, and there's definitely more than 10,000 adults in the United States, so that is met. And the second one is NP greater than or equal to 10 and N1 minus P greater than or equal to 10. So there are 1,012 people, and the P in this case is 70%, and that equals 708.4, which is definitely greater than or equal to 10. And N1 minus P, 1,012 times 1 minus P, which is 0.3. Right, that's 70% do drink, 30% don't drink the milk. And that's going to be 303.6, which is definitely greater than or equal to 10, so that's met. So our conditions are met, so it's okay for us to proceed with a normal calculation. Okay, so we know that the distribution of the sampling distribution is approximately normal with the mean P. We have a P hat, and we will calculate sigma sub P hat. I'm going to slide this down a little bit so that I have some room. And we have sigma sub P hat, which again the formula for that is P 1 minus P over N. So we can calculate that pretty easily. It's the square root of 0.7 times 0.3 P 1 minus P over 1,012. And when I type that in my calculator, I'm going to get 0.0144. I had a P of 0.7 and a P hat of 0.67, and I'm going to look for this area. When it asks for, is this surprising, I'm looking for kind of what's the area here? How likely is it to happen that I get a sample that has a P hat of 67% or less, basically? So I'm going to use my z-score formula. From this point forward, it's pretty much a normal calculation problem. So that's kind of a review over stuff we've done. So we'll use our formula, P hat minus P over, I don't like to rewrite the formula there, so we're just going to write sigma sub P hat, because we already calculated it above. So that's 0.67 minus 0.7 over 0.0144. I type that in my calculator, and I get a z-score of negative 2.08. Now I'm going to use my calculator, and because it's a normal calculation, I'm going to use normal CDF. My min is negative 1 and a bunch of zeros, and my max is negative 2.08, and that gives me an area of 0.0188. So the area is 0.0188, which is not very likely. So is this surprising? I would say yes. This is surprising. Because the probability is so small, 0.0188. So there's only about a 2% chance that this would happen. That's not very likely, so I would be surprised that my sample had only 67%. Okay? So again, if you need to pause that to kind of catch up, or go back and watch it again, that's fine. Now we'll do another example on smoking. So while some non-smokers do not mind being seated in a smoking section, about 60% of customers demand a smoke-free area. What is the probability that a sample of about 120 people had fewer than 50% in favor of a smoke-free area? So the 60% is my parameter. All right, that's the actual proportion of people that demand a smoke-free area. My P hat in this case would be 50%. I want to know what's the probability that 50% or fewer. And my N in this case is 120. That's the total in my sample. So again, the first thing I have to do is check the conditions. And the first condition is the population is greater than or equal to 10N. All right, or 10 times my sample. So the population is greater than or equal to 10 times 120. And I'm going to say that the population is definitely greater than or equal to 1,200. There's more than 1,200 adults that go to customers that demand a smoke-free area. So that's definitely met. That's almost always met. And the second one, we have NP greater than or equal to 10 and N1 minus P greater than or equal to 10. So NP in this case would be 120 times 0.6, and that equals 72, which is definitely above 10. And we have 120 times 0.4, which is 48, which is also greater than or equal to 10. So all my conditions are met. I can proceed with a normal calculation. Remember, the sampling distribution is approximately normal. It has a mean of P, and in this case my P hat is below. So I had a mean of 0.6, and I want to know the probability of being 0.5, 50% or less. My standard deviation of P hat, sigma sub P hat, is again the square root of P, 1 minus P over N, which is the square root of 0.6 times 0.4 over N, which was 120. All right, again, all of this information I'm getting from these three numbers. So that's going to give me a standard deviation of the sampling distribution of 0.0447. I'm going to calculate my z-score. Z equals P hat minus P over sigma sub P hat. All right. Again, that's where I'm at on the graph minus the mean divided by the standard deviation. So 0.5 minus 0.6 over 0.0447. I get a z-score of negative 2.24. And I'm going to use my normal calculations to get that area. That's what it's asking for. What is the probability that a sample of 120 people had fewer than 50% in favor? So the area, once I use my calculator, all right, second bars, normal CDF, min, negative 1 and a bunch of zeros because I'm going to the left, and negative 2.24, and I get 0.0125. 0.0125, which is my final answer.